Question number 5.235. One of the spectral line of atomic hydrogen has the wavelength lambda is equals to 656.3 nanometers. Find the Doppler shift delta lambda of that line when observer is at right angle to the beam of hydrogen atom with the kinetic energy T equals to 1.0 MeV. Okay. So basically in this case, this is hydrogen beam. Okay. And observer is at 90 degree. Okay. And this observer having this much kinetic energy. So this question is based on transverse Doppler effect, because the position of observer with respect to this beam is transferred to it perpendicular to its direction of propagation. And in transverse Doppler effect, frequency received by observer is equals to frequency emitted by the source minus 1 over V upon C whole square, where V is the speed of observer. Right. So from here we can perform some basic mathematics, that is omega 1 minus V by C whole square to power 1 by 2. Right. Again, this V by C is very much greater than 1. Right. So we can write expansion of this as 1 plus nx if x is very less than 1. Right. So similarly we can write this is omega into 1 minus 1 by 2 into V by C whole square. Right. So from here we can we can take some other advantage of this. So let's leave this term right now for that. If we want to calculate the wavelength, okay, received by this observer, then lambda dash must be equals to C upon omega dash, right? So this lambda dash is equals to C upon omega into this factor 1 minus V by 2 whole square to power 1 by 2, right? And this C upon omega is lambda of beam. Okay. So this is lambda, what we wanted to observe, into 1 minus V upon C whole square to power minus 1 by 2. Now we can apply this concept. Actually we are trying to take advantage of this mathematical concept. So this is 1 plus and 1 by 2 V by C whole square. Right? Now see. Here we have to calculate the shift delta lambda. That is delta lambda is equals to lambda dash minus lambda, what is original one, and this is observed by the observer. Okay. So from here we'll get delta lambda. If we'll subtract, use these two equations, then delta lambda is equals to 1 over 2 V by C whole square and into lambda. Right. This is one thing. But here we don't have idea about velocity. Right. So from here we can write that energy is equals to half mv square. It means V square is equals to 2t upon m, and V square over C square can be written as 2t over mc square. Right. Yeah, this is 2t over mc square. Now here we can substitute these numeric values, the value of t in MeV. Okay, so from here we can get V square over C square is equals to 2 into 1.6 into 10 to the power 6 electron volt. Okay, and m into c square. So this equivalent value would be 938 v square over c square, just putting the standard values. So now if we'll get back to this expression, then we can write delta lambda is equals to 1 by 2 into 1 over 938 into this wavelength 656 into 3 nanometer. It's just matter of calculation and we'll get the answer. So from here we'll get approximately delta lambda is equals to 0.70 nanometers.